Well, good deal. Oh, I was going to say, because we're not going back to school at all, I'm sure you got that message, right?
Mm-hmm.
We really have longer. So if we need a little bit more time, I figured I'm going to keep going at this pace, but we'll take maybe a full week or two to prepare for the final.
Okay.
But, at any point, we can speed up or slow down because we don't have to be done now so early. And I don't know what they're going to do about graduation. I think they said maybe later in the summer or something.
We're having a Zoom meeting about that tonight with Mr. Hawk.
Okay. Well, that's good.
Ooh.
All right.
They're going to do that. They might just mail the diploma and say, here you go.
Oh, but how fun is that?
Can't be any less fun than doing it the way we talked about with Mr. Zimmerman last night or yesterday.
How was that?
They want it on the football field and they want to put chairs on like every yard line to social distance. But I was like, it's the beginning of May. There's going to be snow.
Yeah. Or at least rain or cold or windy or, yeah. Yeah. Yeah, there's a lot of schools talking about what they need to do about that.
I think you just get the big screens, just be the drive.
Well, I'm going to go ahead and get started.
Okay.
The objectives today are to identify the common ratio of a geometric sequence. Where an arithmetic sequence, you obtain the next term by adding the same number each time. A geometric is a sequence where we're going to be multiplying by the same number. So instead of having a common difference, we're going to have a common ratio. And so we're going to be able to identify the common ratio of a geometric sequence and find a given term and the sum of the first n terms. So very much like the first objective in the last section, except for dealing with geometric sequence instead of an arithmetic one. And then we're going to find the sum of an infinite geometric series if it exists. In arithmetic series, if it was infinite, the sum just kept getting larger and larger. It went to infinity. You didn't worry about finding it, but a geometric's a little bit different. Okay, a sequence in which each term after the first is found by multiplying the preceding term by the same number is a geometric sequence. The number that is multiplied by each term to produce the next term is called the common ratio. So instead of having a common difference, we're going to have a common ratio. And just like in an arithmetic sequence, we could take any term and subtract the preceding term. In a geometric sequence, we can take any term and divide by the preceding term to get the common ratio. And that's where the term ratio comes up with, because remember, ratio is just a fancy word for fraction or divide. So a sequence is geometric if there exists a number r. So we use d for the common difference. We're going to be using r for the common ratio, such that a sub n plus 1, which means the next term, divided by a sub n, which means this term. So taking any term divided by the term before it gives us r. And again, n, which is the term number, needs to be greater than or equal to 1, because again, having a 0th term wouldn't make much sense. We have a first term, a second term, a third term, so on and so forth. Okay, for each one of these geometric sequences, they want us to identify the common ratio. If the numbers are getting bigger, the common ratio is going to be greater than 1. So the numbers are getting bigger in A. Take any term I'm going to take 48, divide it by the term before it. So 48 divided by 24 is 2. But I could have just as well taken 6 divided by 3, which is also 2. So it's going to be helpful in a lot of these to use the earlier terms because they're smaller numbers.
Right.
In B, if the signs alternate, that tells you that R is negative. And these numbers are getting smaller and their signs are alternating. So I know that R is going to be negative. And to find it, I'm going to put negative 1/2 divided by 1, which is just a negative 1/2. Does that make sense?
Mm-hmm.
Okay. In this money problem, we got 5,200. These numbers are decreasing, but they're all positive. So that tells me that R is positive. So I would take 3,900 over 5,200, which would be 39 over 52, which reduces down to 3/4. You know, just use your calculator on a lot of these bigger numbers or fractions, and then do math inner. I think most of the problems, they want you to list the ratio as a fraction or an integer. Some of the answers, they'll have decimals and have you round, but for R, the common ratio, they usually want a fraction.
Only to call the dealership.
So we've got this sequence that has a common ratio of 2. And this one had the common ratio of negative 1/2. Yeah, they would make a liar out of me. They wrote this as 0.75 instead of 3/4. So even easier to do on your calculator. Okay, here's the formula for the nth term of a geometric sequence. And what's going to be helpful is to write the formulas. I gotta find me a clean sheet of paper that I can, there we go, switch to. And let's go to my document camera and just review a little bit. It helps to, hang on just a minute. I didn't plug in my document camera, which is, the document camera really wouldn't hook up to my computer. So it's actually my document camera with taped a camera you can use for looking down the toilet or something. Come on, did you turn on? There we go. Okay, so it'll be helpful if you have these notes and you have them organized by arithmetic and geometric. So how do we find the nth term of a geometric? Excuse me, of an arithmetic from 8.2?
A sub n equals a sub 1 plus n minus 1 times d.
Good. Because it's an arithmetic, we see an addition sign here. This just tells us how many times we're adding the difference. For geometric, we're going to take the first term times the common ratio. Because it's geometric, we multiply to get the next term, and it's n minus 1 up here. So we're going to come back to that sheet here in just a moment, because we're going to compare the sum of the series too. But if you make this on one sheet of paper and use it to refer to, because I'm not sure if it's in this unit, but the next one, they'll start mixing them up where some are arithmetic, some are geometric. In a geometric, let's say we have, so we're going to say we start with 3 and the next term is 6. So is this geometric first?
Yeah.
Okay, what would R equal the common ratio?
2
Uh-huh,
or yeah.
yep, we're multiplying by 2 each time. But like the arithmetic, even though this is showing 6 terms, we've only multiplied by 2 5 times. It's always 1 less than n, because we have to start with the first term, and I'm just trying to explain why this is an n minus 1 instead of an n. Come on, you can do it. Sometimes I have to talk to my computer. It doesn't know what. All right, there we go. The nth term of a geometric sequence and is given by this formula. And again, we have n greater than or equal to 1 because n is the term number. So if we want to find the 7th term of the geometric sequence 4, 20, 100, first we're going to identify R. What are they multiplying by each time?
5.
So the first term, a sub 1 equals 4. N equals 7 because they want the 7th term. And the common ratio R is 5. Now we just plug that in the formula. So a sub 7 would equal 4 times 5 raised to the 7 minus 1 or 6th power. And I would just plug all that in your calculator. And I can't remember which calculator you have, but I usually subtract the 1. So this is the part that I would put in my calculator.
Okay.
The parentheses here are not required, but if in doubt, throw them in there. Geometric sequences grow very quick. So the 7th term was 62,500. So you'll probably be getting a lot bigger numbers or a lot smaller decimals than what we did with arithmetic. Okay, S sub n is the sum of a series. And to find this, we need to know the first term, we need to know R, and we need to know n, but we usually know n because they'll say find the sum of your first few things here. Now, this will work as long as R is not 1. Of course, it wouldn't make sense to have a common ratio of 1 because
Right.
multiplying by 1, it doesn't change it. So generally, we don't have an R of 1. But if R were 1, it would make it undefined because we'd have 0 in the denominator. So here is one in sigma notation. Find the sum as k goes from 1 to 11 of 0.3 times k. Now, I know that this is a geometric series because they're multiplying by 0.3 each time. In the arithmetic, they were always adding. So in sigma notation, in arithmetic, they had a multiplication problem here.
He hasn't given me any details on it, Mom.
Yeah.
I can tell you that all week.
So in the notation, remember we can find n by taking the top minus the bottom, add 1 back. Of course, if they start at 1, it's just the top number of 11. The first term you can always get by plugging in the bottom number. So 0.3 to the first power is 0.3. R, the
How did
number,
they get 3 in?
excuse me?
How did they get 3 in the top?
That's
Oh,
supposed to
because it's R.
just be
Oh, it says it. Oh, it's supposed to be 0.3.
this down here is supposed to be.
Okay.
Yeah. And I think in the
Nope.
decimal out. Oops. Let me. I'm just going to plug this in my calculator. You might want to plug this into the parentheses here on top are required. And you'll need to put the denominator in parentheses. And don't forget to put in 0.3. Divided by. This is just a good one to mess with.
I got what they got.
Okay, yeah, that was just a typo there. I did it as well, so it took me a lot longer than it did you. Okay, the sum of an infinite geometric series, that's where one just continues. The only time you'll use this formula is if they say it's an infinite geometric series, or sometimes you'll see S sub infinity sign, or if it doesn't say find the sum of the first 8 terms or something like that. A lot of students want to use this formula because it's much easier than the last one. So here's the formula, and a lot of times we do S sub infinity equals A sub 1, the first term divided by 1 minus R. But that's only when R is between -1 and 1, non-inclusive. So one of the things that's going to make this a little bit harder is that you have to remember to check this, because if R is not between 1 and 1, you'll still get an answer. It'll just be wrong. So let's look at an example. These are both series because they have plus signs between them and not commas. A sequence, you'd see commas. A series, you'd see plus signs. Is this a geometric series?
No, because they're adding.
No.
Well,
Series
looks like they're adding.
How would you get from the first term to the second term? Would you?
You multiply 3.
Right. So because you're multiplying by 3 makes it geometric.
Right.
All series will have plus signs between them.
Oh, okay.
But because we have to multiply to get each next term, that makes it geometric. R, yeah. So R in this case is 3. Is 3 between -1 and 1?
No.
No. So this is one, the sum does not exist. In fact, if you think about it, when you take 1 plus 3, you get 4. 4 plus 9 is 13. 13 plus 27 is 40. This is just going to keep getting bigger and bigger and bigger. So we wouldn't actually be able to find a sum. Down here, is this geometric? And if it is, what are?
It is, and you're multiplying by a half or -1/2.
-1/2. And one of the things I want to talk to you about in a minute, if I remember here, is when all the signs are negative, that still means that R is positive. The only time R is negatives are when the signs alternate. But you are correct. R is a -1/2. Is that between -1 and 1?
Yes.
Yes. So we will be able to find the sum of this infinite series. So here the series does not have a limit or does not have a sum because R was greater than 3 in A. In B, it did. So we put the first term over 1 minus R. So -2 over 1 minus a -1/2 would be a -2 divided by 3 halves, or if you put 1.5, that's fine. but I think they will want the answer as a fraction, so you can do the math inner. If you use your calculator to find this, make sure you put the 3/2 in parentheses. Otherwise, your calculator, if it just sees -2 divided by 3 divided by 2, it thinks those are all equal, and it does the divisions from left to right, which will give you a wrong answer.
Right.
So, suppose that someone offers you a job for the month of September, which has 30 days, under the following conditions. You will be paid 1 cent for the first day, 2 cents for the second day, 4 cents for the third day, so on and so forth, doubling your previous day's salary. How much would you earn? Would you take the job? Make a conjecture before reading further. So first, how much do you think you would make at the end of the month?
Well, if it goes on like that and September's 30 days, you would only be making 30 cents, wouldn't you?
Well, you would think so, but we're actually, this is going to be a series because we're going to add the amount you were paid on the first day plus the amount you were paid on the second day plus the amount you were paid on the third day. So this is a series. Is it an infinite series or a finite series?
It's finite because it only goes to 30
Good.
days.
Good. And is it arithmetic or geometric?
Both.
Well, the series,
Well,
it has to be one or the other, but ask yourself how you get from the amount you're paid the first day to the second day to the third day. Are they adding the same number or multiplying by the same number?
well, the solution says they're multiplying by 2, so.
Yep, because you double your money each day, and double just means times 2.
Right.
So times 2 is 2 cents. 2 cents times 2 is 4 cents. 4 cents times 2 would be 8 cents. So R here would be 2. So we're going to look at the formula for geometric series, the S sub n, since it was finite. Does that make sense to you?
Mm-hmm.
And on top, we're going to take the first term, which is 1 cent, times 1 minus 2 to the 30th power. And that whole thing divided by 1 minus 2, or divided by a -1. So I just put in the numbers from the problem into the S sub n formula, which is right here. So 1 cent times 1 minus 2 to the 30th divided by 1 minus 2. At the end of the month, you'd make $10,737,418.23.
How about that?
Yeah. Geometric series increase very quickly, and it's all due to this. We took 2 to the 30th power. So we did 2
Right.
times 30 times, which made that number really large. So if you put this in your calculator, and we might want to just try that for practice to make sure you can get that in there. Remember, the whole denominator has to be in parentheses, or usually it's just 1 minus r. I can, unless it's a fraction or decimal, I can subtract that in my head. Yeah, did you get exactly what they got?
Yeah.
And the one thing you have to be careful of, if you would have put just a 1 here for 1 cent, you would have been fine, except for that meant your answer would be in cents rather than dollars, and you would have had to move the decimal 2 places. So
I did that, so
excuse me?
I'll remember. I said I did that, so I'll have to remember not to.
Yeah, well, and it doesn't matter as long as you make sure that the first term you put in, if it's in cents, your answer is in cents. If you put it in dollars, like they did, then your answer's in dollars. So just be aware of the difference between cents and dollars on these type of problems.
Okay.
All right, and I will show you one other thing. Morning, Gideon.
Morning.
And I have no problem with you guys muting while we're going through this. And I didn't know if you know, pressing the space bar allows you to reply without clicking the unmute. It's just that while you hold the space bar down, you're unmuted.
No, I didn't know that.
Oh, I didn't know that either.
I mean, you can try it if you want. Mute and try it, and I'll tell you. And then, you know, press the space bar and say something like "Good morning," and I'll tell you if it works. I haven't tried it.
Good morning.
Good morning.
Yep. So I heard both of you say good morning, and so you're welcome to use that. And that way, if I ask you a question and respond, you just press the space bar and hold it while you speak. And all right. So what was the sum of an arithmetic series? What was that formula, just to get it on our formula sheet?